Hello, I'm Andres Garcia. I hope you're having a great day, and in this video I'm going to be showing you everything you need to know to get your robot moving during driver control. Now the first thing you're going to want to do is open an existing competition template project, and if you don't already have one, make sure to check the previous video where I guide you through that. The first way you can do this is looking at your recents over here. You can then click on the project that you want to open. So in this case I want to open first program. There's another way to do that, in which you can go over here, hit open recent, and then click on your project as well. But if for whatever reason you can't find it here, you can always go to open. That'll bring this up here. Then you can click on documents, hit VexCode-projects, then click on the project you want to open, and then click your project name .v5 code file. Double click that, and boom, you're going to be back into the project that you wanted to edit. The first thing we're going to want to do is set up our motors and our controller. So if we go over to robot configuration, I've set up a 7-motor robot with a 4-motor chassis, a 2-motor lift, and a 1-motor intake. I've also set up my controller. Now one very important thing that I did here is I actually reversed both of my both of my right motors. So here you can see my front right motor and my back right motor are both reversed. And that's because of something I'm going to show you guys right now in this graphic. If you take a look at this graphic, you'll see here that when you apply positive power to a non-reverse motor, it spins counterclockwise. And when you apply negative power to a non-reverse motor, it spins clockwise. This makes sense for the left side of our chassis. As you can see here, if I apply positive power, I'll move my wheel this way, causing it to go forward. However, if we look at the right side of the chassis, a non-reverse motor, when we apply positive power, the wheel is going to spin backwards, which is actually going to cause our chassis to turn to the right, which is not what we want to do. So therefore, we reverse both of our right motors, and that actually flips these around, meaning when we apply positive power, the wheels will spin clockwise, and that'll cause our whole chassis to move forward when we apply positive power. Now, before we jump into programming our actual robot for driver control, it's important to understand how driver control code works, and how these sticks and these buttons work. Each one of these sticks has this XY axis on it, and that can be a maximum of 100 in either way. Meaning that if I move this stick all the way to the right, it's going to give me 100. If I move it all the way to the left, it gives me negative 100. If I move it all the way up, it gives me positive 100. And if I move this all the way down, it gives me negative 100. This is really important to understand when you're programming your drive control for your chassis. Another thing to know is that all of these buttons have a Boolean assigned to them, which is a variable that returns true or false exclusively. And whenever you press one of these buttons, your variable changes to true, and when you let go of it, it becomes false. This will become very important later, and I'll remind you about it soon. Now when it comes to programming an omnidirectional chassis, you have really two main options. The first is called arcade drive, which means that this stick's y-axis is fully in charge of the forward and backwards, and this stick's x-axis is fully in charge of your left and right turning. So in this case, when we're trying to move forwards, all you would have to do is move this stick up, and your whole chassis would move forwards. The other option is tank drive, which basically means each one of these sticks' y-axis represents half of the chassis. Meaning if I move this stick all the way up, I give full power to my left side of my chassis, and if I move this stick all the way up, I give full power to the right side of my chassis. So if I move these up simultaneously, I'll move my whole robot forward. When it comes to turning, this is where they differ quite a bit. For arcade control, all I have to do is move this stick to the left in order to turn left. However, if I want to turn left with our tank control, I have to move this stick down, my left stick down, and my right stick up. That's because when you want to turn in a direction, you always apply negative power to the direction in which you want to turn. So in this case, when I bring this stick down, this left stick down, I apply negative power to my left side of my chassis, causing it to turn left. One quick thing I wanted to show you guys is now that we've set up our motors in robot configuration, we can actually see that VexCode will generate that code for us right here, which is pretty cool to look at. Next, I'm going to show you guys how to actually program both tank and arcade drive. If you look here, this is going to be our arcade drive code. And while this may look daunting at first, let's break it down. This first part is just saying what motor we want to move. This part right here is saying that we want to move the motor. This says what direction we want to move the motor in. And this says the power at which we want to give the motor, which can be all the way from negative 100 to 100. And this says that we want to give that power in percent, meaning that if we give it 100% power, it's going to move 100% of its speed, right? Now, this is the most confusing part of the arcade drive code. which is understanding this middle part, but it's really not as complex as it may seem. You may remember that I told you that each stick has its X and Y axis, and it returns that value. So right here, we say, I want my controller axis 3 value, which is actually going to be whatever value this y-axis of this stick is returning. I then ask for my axis 1 value, which is asking for whatever value this axis is giving me, the x-axis of my right stick. Now, this whole expression is saying add the value of both of those axes together, and that's going to be my power. This makes sense, as if you think about it, this axis 3 is my left stick, right? So I'm saying, hey, give me my left stick power. So if I'm moving my left stick up, I'm going to move forwards. If I'm moving my left stick down, I'm going to move backwards. And then I'm also taking into account that right stick. This is asking to return the value of the x-axis of my right stick. And it's asking to add it to my previous value, meaning that we're going to take the positive value of the right stick x-axis, okay? So if we move this stick all the way to the right, we're going to give positive power to the left side, which makes sense because we actually will end up giving negative power to the right side. As you'll see here, both of my right motors, which you can see by the R, receive the negative value of this right stick. So when I move it to the right, I give this negative power, which will actually cause the right side of my chassis to turn to the right. Now, tank drive is a little easier to grasp conceptually, as it's really just asking to give the left side of my chassis, so both of my left motors, are going to give power equivalent to the value of the left stick's y-axis. For the right side of the chassis, it's the same concept, but we're just asking for the right stick's y-axis, and that's why we end up getting all of the left side of the chassis movement on the left stick and all of the right side of the chassis movement on the right stick. Essentially, all drive code, except for chassis code, uses if, else if, and else statements, which is why it's really important that you understand these concepts. So let's break each one of these down. For if statements, you can kind of think of a vending machine. If I press the button for Sprite, for example, I'll get a Sprite in return. So really what this is checking for is if I press the L1 button, which is this button right here that you can see, the first bumper closest to us, then it'll cause my intake here to spin forward, so probably intaking in this case. Else if is like an if statement, but it only runs this code inside of it, if this condition above has not been met. Meaning, if I was pressing L1 and L2 at the same time, the first part, the L1 code, would actually trump the L2 code. After it rules out that this first part isn't happening, which is what this else comes in for, it'll check the if part of it. And this is just treated like a normal if statement, which checks if this condition is true. So in this case, it's if we're pressing button L2, it'll make our intake spin in reverse, which will most likely outtake. The last part here is an else statement. Else statements only run if all of the conditions above it are not being met, meaning that if I was pressing either of these buttons, the else wouldn't run. But if I was not pressing any of these buttons that I mentioned here, so L1 or L2, then my else statement code would run, which in this case is stopping my intake. Now for stopping, VexCode provides 3 different types of stops: coast, brake, and hold. Coast is like slowly pressing the brakes on a car, meaning you'll slowly cruise to a stop. It's not great for precise movement, but it's great for things that you don't necessarily need to stop right away. Brake is the opposite. It's like slamming the brakes on a car. It'll stop instantly, which can actually end up hurting some of your motors, so you should only use this when you absolutely need something to stop. And hold works in a very similar way. It's like slamming the brakes and then holding them, meaning that you can't actually end up moving it until you stop holding it. This next part of the code is very similarly structured, but it's for the lift code, which would use 2 motors. In this case, I'm using a very similar concept, just with different buttons here. As you'll see, this is R1. And then I'm just making 2 motors move. This right here, putting both of this inside these curly brackets, will make both of these things occur when this if condition is met. So here it'll move both of my lift motors, making my lift go up. This part will make both of my lift motors go down, which will make my lift go down. And this part right here is just saying if none of this is happening, make sure my lift is stopped. I should also point out that we write all of our code inside the void user control. However, it's also very important that most of your driver control is inside this while loop. This while loop basically makes sure that throughout all of user control, it constantly is checking for all of your button presses and all of your code, while if you were to put it up here in this line, it would only run at the start of driver control. Now, that's actually going to be it for most of your driver control. A good thing to remember is that, like I said, this chassis code, you can change it to however you want. So if you wanted to maybe switch the axes in which maybe your right stick in your arcade drive moves you up and down and your left stick moves you left and right, then you could totally change that by just looking at your controller and figuring out which axis that is. You could also totally change which buttons move your lift up and down and all of that. It's really all about personal preference when it comes to drive code. Now, there's one more little tidbit of information I'd like to leave you off with before I end this video. As you'll see, I left a lot of these notes here, like coast break and hold here, and arcade drive, and this diagram right here. You may wonder what this actually does, and the actual answer is literally nothing. These are really just notes I leave to myself, and they're called comments in code. Comments aren't actually read by your robot, meaning I can write anything in here, and it won't actually read this. And the way that we show that something's a comment is by putting these two slashes before it, and that lets the code know, I don't want you to actually process this. This is really useful if you're going to take something out of your code. Instead of just deleting it like this, I could instead choose to comment it out. And if you want to comment out multiple lines, you can hit one slash and then hit the star. And then when you want to stop that commenting, you can hit the star and then the slash. And let's say I wanted to change my chassis code, but I wanted to still reference it. I could comment this out and then write my code below it so I can always refer back to it. This is also good for if you want to test something and then refer back to old tests, but you don't want that in your code all the time. Now, with all that being said, that's actually going to be it for this video. Thank you for sticking around, and I hope you found this useful. Thank you, and goodbye.